Hi everybody, this video today is going to talk about lesson 4.4, which is graphing stories. This is one of my favorite topics in this class because I just think it's fun to look at the different graphs and see what they might represent. Okay, so when we look at graphing stories, what we have to look at is the entire graph. Sometimes there's a title, but oftentimes there's not, and that's kind of the mystery is, okay, if there's no title, then what does it actually mean? Which is why in science class, your teacher wants you to put a title. Because there's no title, they don't know what it's talking about. But we do have axes labeled, and so we definitely know that this is a distance time. So we're comparing the distance over time. So you can think of the bottom, like, I don't know, let's just say it's minutes. And so it's 1, 2, 3, 4, 5, 6, 7, 8 minutes, let's say. Okay, same thing over here. We're looking at distance and time. They're the same on the axes. And again, we could say, well, maybe the x-axis is minutes, and if we count 1, 2, 3, 4, 5, 6, 7, 8, then we can look at the graph and see what it's talking about. When we look at the graph, the main thing that we're going to be looking at, we have to look at the axes to see how it's set up, but then what we're really looking at is the line itself. So this line, what is that line doing, and what is this line doing? And so as we look at these, the question, which of the following could represent a car sitting at a stoplight, and what could the other one represent? Okay, if this is a stoplight, it's a really long stoplight because I made it 8 minutes long. So this one would be where the car is stopped. How do I know that? Well, because the distance does not change. The distance stays the same. Well, the distance is staying the same, you're just sitting there, okay? This one, though, the distance starts at 0, so it's important to look at the y-intercept, and then what's happening after that? Well, the distance is increasing. And so the distance is increasing, that means it's getting farther away. And so maybe this is a situation where, if we're talking about the car, then maybe you're actually driving the car, but it's perfectly flat. Like it is diagonal, but it's a perfectly straight line, right? So maybe you're driving with cruise control. And I think we've talked about cruise control before. Cruise control is where there's like a button on your car that you can set it and stay at the exact same speed the whole time. So if you set it at 25, you're going to be going 25 miles per hour the entire time. And so that's what's happening here. This is going at the exact same speed the entire time. Okay, so let's look at that in terms of these. This time we don't have distance, we have temperature. We still have time on the x-axis, and that's very common. Almost always we will have time on the x-axis. I said almost always. Not always, but almost always. Okay, the air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Let's take this piece by piece. The temperature was constant for several hours. Okay, if it is constant for several hours at the beginning of the day, it cannot be this. Why do I say that? Because this one's flat at the beginning, this one's flat at the beginning, so it's constant at the beginning, but yet this one like rises up, so it's not this one. Then, rose steadily for several hours. Okay, that's rising here, we could be the same so far. Then, this is the next sentence where it's pretty important. It stayed the same temperature for most of the day. Okay, look at the difference. We have this one staying the same temperature for some times, but this one, doesn't it look like it's staying the same temperature for most of the day? I'm leaning towards graph B. I think the answer is graph B, but I'm going to finish it off. Before dropping sharply at sundown. Okay, this one drops sharply at sundown. This one drops sharply, but then it stays. That part, there's nothing in the words about that piece. And so I'm not going to choose that. And this one looks like most of the day. Like this flat part at the top is a very small part of the day. This flat part is most of the day. So I'm going to say that the answer is graph B for this one. Okay, this time we've got a matching. Let's see what's going on. Okay, a person alternates between running and walking. If you look at these, which one looks like they're alternating between running and walking? This is like, alternating means like goes back and forth, okay? So if it's alternating, it's going back and forth. I think graph B is the one that's alternating. It's going up and down and up and down. That's going to be graph B. The next one, a person gradually speeds up to a running pace. These both have a gradual start, right? And then running pace. Okay, so let's go to the next one and see. A person walks, gradually speeds up to running pace, and then slows back down to a walk. Okay, look, that's this person. This one doesn't have a slow down part. So that's not there. This one does have a slow down part. And so this one's going to be C, and this one is going to be A. This is a difficult one because I feel like unless you've really paid attention to how water fills, it's really hard to know. So suppose you pour water into each container below at a steady rate. I actually tried to make some videos of this one time and it just didn't work out very well. Match each container with the graph that shows the change in the height of the liquid in the container over time. Explain your choice. I'm going to start with the easiest one. Do you see how these sides are perfectly straight up and down? And so if you're pouring water in there, and this is most of your cups at home are probably like this, if you pour water in there, it's going to rise up at the same rate the whole time. There's no change, so that one's going to be that one. Now the next one, it has a different shape to it. Like on the sides, it has this shape. And this one also has a different shape, even different from that one. And so we have to think about what happens in these situations. I want to think about this one. Imagine you're filling up water, and it's like you're filling up, filling up, filling up. Well, isn't it, let me back up a step. Let's say it was like this. Wouldn't it fill the bottom part quickly, and then as it got towards the top, it would slow down because you have more space to fill? Okay, so then if it went back down this, it would go faster again. Does that make sense? So I think this one's going to go with that one because this one fills up pretty quickly at the bottom because it's so small. And then in the middle part, it takes longer to fill up, so it doesn't fill up so quickly. And then at the end, it's like, oh my gosh, all of a sudden it's this tiny thing and it fills up real quick at the end. Now we're left with this one, so let's just make sense of it again. Again, since it's a smaller space down here, it's going to fill up faster. And then when you get to the top, it's a wider space, so it's going to be slower. And so this is the faster portion, and this is the slower portion. All right, let's turn the page. All right, here we go. We have some stories to tell. When you do these problems, what you need to do is you need to look at each section of the graph differently, or individually, I guess I should say. So each section of this graph we need to look at individually. So the first part, they're moving, but not very fast. So maybe I'm going to write that down. So during part A, they're walking really slowly. Part B, or driving slow or whatever. Part B, they are actually stopped. Part C, they're going pretty fast. And then part D, they're going slow again. So we need to come up with a story that's slow, and then stopped, and then fast, and then slow. So I came up with a little story. It might not be the best story, but it is a little story. So I had to walk to my car, which is parked a few blocks away. I stood there for what seemed like forever trying to find my keys. Finally, I got into the car and sped down Metcalf. At the end, I turned onto a side street where the speed limit was 20 miles per hour. And now that I've looked at it more carefully, that last part where the speed limit was 20, that actually, if part A is walking, part D should also be walking. Why do I say that? Because they have the same slope. So I think what I said here in the very last piece, I think I should change that to walking. But it's important to see that you say that something's going on slowly, and then it stopped, and then faster, and then slow again. All right, remember, it's important to look at the axes. So this is water level. What does that mean? Well, we're filling something up with water. So during the first part, part A, it's filling up, and then it stays that same level, and then it empties out. It does have these little curvy parts, and there's a couple of reasons for that, and I tried to talk in my paragraph about how it slows down at that part. So I don't know what it is. It could be a pool, it could be who knows, but I said it was a measuring cup. So I had to fill a measuring cup with water, so I turn on the water and fill it up. because when you turn on the water, it's a constant rate and it fills up pretty quickly. At the end, I turned off the water. So that's where this is. Like you turn off the water and it like kind of turns off, not instantaneously. You know, when you turn off the water, it like takes a second to turn off. Then it's flat. What happens while it's flat? Well, I place the cup on the counter while I mix the other ingredients. And then when I'm ready for the water, I poured it slowly at first into the bowl with the other ingredients. And then I poured it out real fast. So that would be a story that you could go with that. And again, these stories, there's no right answer. Like you can come up with anything. All right, once again, this one we're looking at what's going on in each part. I didn't change. This didn't have a y-axis, so I'm just saying, let's say it's distance from home. That's an easy one, so let's just say that. So you are far away from home here when you start. And then you're walking towards home. And then you stay somewhere for a minute. You don't move. And then you go back to wherever it was you started from. So here's what I say. I was at my friend's house. That's on the y-axis. And I started walking home. I was almost home. See how close I am to home? When I couldn't find my phone. I looked in my pockets and my bag, but I could not find it anywhere. Okay, you're standing here like looking. You realize you left your phone. So you have to turn back and go back to your friend's house to get the phone. Okay, how about tables? How are they going to play into it? Well, tables give us more specific information. Like up here, there were no markings. There's no, 1, 2, 3, 4, 5. We don't know. So here we have a table, but we don't have markings, but we can look at some things. Some things I want to look at is the y-intercept. The y-intercept is going to be at the beginning. And so at time of 0, what's happening? That's one really key thing to look at. Another thing to look at is patterns, like this one's going down, 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 down. This one is going up pretty fast, but then it slows down. Okay, so the one that's going down, 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 that's this one. So this goes with J. This one is going up. It's going up pretty fast. And then at the end, it slows down. So like what I'm saying is from 0 to 45, that's a difference of 45. And then 45 to 80. So those are pretty big differences. But then down here, it's only 120 to 125. And so it's a slower piece right there. And so that's going to go with that one. Okay, we are going to have some fun activities to do in class when we come back for this. So I hope that you look forward to these activities.